is how we recorded the different times and everything, and then how we calculated them to come to the acceleration, which should have been around approximately 10 meters per second squared. So the known equation that we have is that the distance equals 1/2 acceleration times the time squared. So this time is, remember, the average time. Okay, and then the distance we know, which is 10.65 meters, which was told us from Mr. Nyman. Okay, so then we have the distance, which is 10.65, so now we're just going to plug and chug. So now over here we have 10.65, which is equal to 1/2 the acceleration, which is what we're looking for, times the time, the average time, which we took the averages of, was 1.63. Okay, squared. So from here it's just simple algebra. We just simplify. So here we're going to do 10.65 is equal to 1/2 the acceleration. Once we square the average time that we have, it comes out to 2.66. Okay, so now what we're going to do is we're going to divide this 1/2 and just get this fraction out of the way. So when we divide by 1/2,
by giving these trials, we're trying to...
dividing by 1/2 is the same thing as timesing by 2. So we get 21.63, we're coming over here now. So I have 21.3, which is equal to, now we have this 2.66 in the A, and 2.66 being the coefficient and the A being the value that we're looking for. So then we have 2.66A. Now we're going to divide this to isolate the variable A, which is the acceleration that we're looking for, which is divided by 2.66, and then the acceleration is going to come out to about 8.01. Okay. So that's the acceleration that we got, meters per second. So this is the acceleration that we got. We know it's obviously not really close to 9.8 meters per second, which is the actual acceleration that we know. So then we moved on to calculate our percent error, which is over here. So the percent error is the absolute value of the known minus the recorded value. Okay. Divided by the recorded value times 100 to get that percentage. So our known value is 9.8.
It'd be so much fun if we could do like a watermelon.
Minus 8.01, which is the value that we measured.
So much fun.
Divided by the recorded value one more time, which is 9.8. Then we have to times that by 100.
We need to try this old alleyway.
So once we do that, this will come out to 1.78. I'm sorry, 1.79. Minus, divided by 9.8 times 100. Okay. This is going to come out to 0.183. And we times this by 100%, which gives us 18.3% error. So now just to finish off, the acceleration that we know is 9.8 meters per second. The acceleration that we got was 8.01.
I just wanted to make sure that she did all of it.
Okay, so this one is the known. This is what we calculated. And there's obviously percent error consistent here, so we have the percent error of 18.3%. And that's the acceleration that we calculated.